So let me continue. We have a client server, and based on the current plot, we have this one. Client server, P2P. And this one, it says P2P can have the maybe shorter time, possibly shorter time than the time required for the client server. And so that we think P2P will be scalable. So because of this, we have the P2P rather than client server. And also, look at this, the time going through as n goes up. However, it doesn't mean we have the straight line. Actually, we have a bit flat trend for the P2P. So we expect P2P rather than client server. However, we have that way to have the lower bound rather than the tight bound. All right, and we have some story about the P2P. We already have a file distribution that says file sharing. So we take the example from BitTorrent. And BitTorrent, we have the data chunks. What that means, chunks, it says it's the small, actually the small data size. So we have chunks. The current chunks, actually, we have the current size, 256K byte. Okay, it should be a K bit, sorry. So K bit. So we have KB. And peers actually in torrent will send and receive the file chunks. Based on file chunks, we have the transmission. Sending a file, receiving a file. And we have the tracker. Tracker actually will track peers participating the torrent. Previously, we didn't know. Oh, we don't have always on server. But why here we have always on server tracker? Well, this is a special server, but we care about this one. No always on, so we care about torrent. And torrent actually we have the self-service provided by peers. And we don't have the server involved in the actually the file distribution. So within this is P2P, right? So right now we have the new arrival. Can we find the other peers from the system? Yes, from the tracker. Then we can have the possible information. So it doesn't mean a new peer, Alice cannot find the other peers. No, still can pass on the tracker to find the peers. So of course we can send the request and get the data chunk from the other peers. And likewise we can have the other one, perhaps we call Bob. All right, within BitTorrent actually we expect this. Peer joining torrent, initially no chunks, but it will accumulate chunks over time from the other peers. And actually we have the tracker, so we need to have the registration with the tracker. And so that tracker can know the peers. All right, and right now we might to download the file. And also upload the chunks. And it will change the peers. All right. So you see, something like this. The current way, it is called churn, right? So what do I mean churn? This one. Or maybe name actually way to explain the term churn. Summarize, we have the way to have the transport the milk and making milk into butter. And so that we need to move quickly. Move quickly here, you see? So that's why I try to move quickly so that you can feel. Yes, we have summarized a churn here for the actually for the torrent. So because of the fact peers may go and come and go, so we have summarized, okay, come and go. So we have the churn, and we call it churn for the P2P. Well, because come and go, so is it possible to have one peer get the entire file, but leave directly? So using a selfish manner. So selfishly leave, it's possible. Or maybe, okay, the peer received the file chunks, the whole file chunks, but still remain in the torrent. And so it says the peer altruistically remain in the torrent. So is it possible? Yes. So we have the two extreme types. One, selfishly leave, and the other one, altruistically remain. All right, altruistically remain. Okay, forget it. So the two terms, altruistically, that says this one. Or maybe about this. So the story about P2P in BitTorrent, it says requesting chunks. All right, periodically, and we may have the missing chunks, etc. But the important one should be we have the special working mechanism called tit for tat. Tit for tat for BitTorrent. It says edit send chunks to those top 4. Top 4 peers currently sending her chunks at highest rate. So tit for tat says edit find the top 4 senders, top 4 peers sending chunks at the highest rate, and so that edit send at highest rate to the top 4 peers as well. But the top 4 will be re-evaluated every 10 seconds. So every 10 seconds, re-evaluate the top 4. Every 10 seconds, re-evaluate top 4. However, every 30 seconds, randomly select another peer and just start sending chunks to that peer. Don't care if top 4 or not, but just one. So we have a top 4. However, every 30 seconds, we have a top 3 plus random selected peer. Randomly selected peer. And for the randomly selected peer, we send chunks to the peer. And we don't consider the others, just send the chunks to that one. And this mechanism, we have the special name. The name is called the optimistically unchock. This peer. So the newly chosen peer join the previous 4 peers. Previously we call it top 4, but we have a top 3 plus the current one, and the current one can receive chunks. So this is a special mechanism. We call to this peer it receives a chance. So for example, Alice using the optimistic and chalk manner to send chance to their peer. So let us have the checking for the terms, tit for tat. All right, and later we have optimistically, and chalk or unchalk. So optimistically and chalk, you see unchalk. So unchalk says, okay, send continuously, contiguously, don't stop. And optimistic says, okay, I feel everything's okay, just send the chance to their peer. All right, so look at this, tit for tat, and optimistic and chalk. So normally we should have a top 4. But every 30 seconds, we select one to serve as the possible one to unchalk. So Alice optimistic unchalk Bob. So maybe Bob is the newly joined peer, and every 30 seconds, Alice actually optimistically unchalk Bob, right? And use it to serve as the so-called top 4 provider, even it is not this one. And Bob becomes top 4 of the current top 4, Alice top 4 provider. Well, one turn. Okay, and reciprocate here, the meaning here, it says, okay, Alice select Bob. Likewise, Bob treat Alice the same. So still have the manner of tit for tat. But maybe Bob, it is not the top 4 peers. However, it still serves as the top 4 working mechanism to send the chance to Alice. All right, at least for the current situation, Alice randomly select Bob to optimistically unchalk. All right, so of course Bob using the same manner, using the tit for tat manner to treat Alice. So of course need to send chance to Alice. All right, so this is the special approach, tit for tat and optimistic unchalk, adopted by BitTorrent. So I think you know this reason. Because of the reason, so here we have one question. For example, using Alice again. Alice is a new peer, right? A new peer in BitTorrent. Actually, Alice is a new peer, and actually it won't be the top 4 providers. So how Alice can have the chance? And this is the first chunk. Actually, we can pass on the optimistic unchalk. Of the BitTorrent, and so that Alice can get her first one. How? For example, Alice using the optimistic unchalk and chosen by some peers, and so that peer will send the chance to Alice. So it's really important. If we don't have the optimistic unchalk mechanism, none of the peer can receive the first chunk from the torrent if the peer is a new peer. So to take care of the possible chance for the new peer, we need to have that special mechanism, optimistic unchalk, every 30 seconds. So this one is really important in BitTorrent. All right, so likewise that you have 1 minute to think about the P2P architecture and the mechanism tit for tat, optimistic and chalk of a P2P network. Okay, think about this for a few seconds. All right, so let us continue. So next one, we talk about video streaming and content distribution network, CDN. And we talk about context or content, right? Content. So the current content actually, we talk about video. And we have a streaming. Yes, the streaming same as the current streaming on YouTube streaming. So we have a video streaming. Current one is YouTube video streaming, right? So stream video traffic. In fact, we have the major consumer of internet bandwidth to check stream video, right? Netflix, and I don't know streaming from YouTube, right? But YouTube, it is not the major one. Netflix, we have the major consumers. Netflix, and actually Amazon, we have Amazon Prime, and put them together. The traffic actually, it should be 80% of residential ISP traffic, and the record taken from the report in year 2020. Well, we have the major one because we want to watch, for example, movies. So movies in video. So we have the video and video transmitted through video streaming. So we have the major consumers of internet bandwidth by checking the video streaming. So if I want to send the video, and then we should have the suitable architecture. Well, so you will have the challenge. How to have the scalable one, and how to have the small size to a really huge size, 1 billion users. If so, how about a single mega video server? Mega says a really huge video server. Here we use the term mega video server. If a single one is okay, it doesn't work, and also it won't work. Why? Because the load is really huge. So we have a really huge burden on the single mega video server. So it doesn't work, or it won't work. And furthermore, we have the heterogeneous scenario. So the second challenge should be heterogeneity. Different user with a different capability, right? And so it should be a challenge as well. And how to have the solution to send the video? We should have the distributed manner and application level infrastructure, and so that we have the video streaming to form the CDN. Well, to have a CDN, let us go through multimedia quickly. First of all, we have a video. And video, then we have these. We have the spatial coding. And we have a frame, right? And we have a frame, so different time. And time we have a temporal coding. So we have a spatial coding. Spatial, actually it's the space. So coding based on the space, so we call the spatial coding. And next one, based on time, so we have a temporal coding. All right, so we have the two types of coding, so that we have the different frames for the video. Well, video, it should be sequence of image display at a constant rate. For example, 24 images per second, and digital image. All right, and so that we can have the smaller element we call pixels. And each pixel represented by bits. All right, so within the frame of the video, we use pixels, and pixel form the frame. Well, something like that. And we have coding, and coding actually use redundancy within and between image and some number to have some line. Okay. To decrease the number of bits used to encode the image. Why? If we always have the whole and the whole, then we have multiple volume. And sometimes we just have the actual one. The actual one, so we can decrease the number of bits to be used to encode the image. So that's why we want to have the encoding mechanism for video. And two approaches, spatial and the temporal. So spatial and temporal, right? Spatial or temporal. All right, so spatial and temporal. So these are two approaches to encode. Well, about rate, we have a constant rate, and we may have a variable bit rate, and so that we can have the possible spec MPEG 1, 2, 4, and so that we have the different rate. Well, and streaming store video. First of all, store video. This is a simple scenario. Okay, store, right? And send. And if we don't have any delay, so currently the delay is fixed. But for the network, we won't have the fixed delay. So we won't have the uniform delay like this. So currently, at this time, client playing and the others, we have the same delay. So we have the smooth playing. However, we don't have the fixed delay. We will have the variable delay. And so that variable delay causes jitter. So actually, we will have the interactive, actually to have the proper interactivity. And pause, fast forward, rewind, jump through the video. So we need to have some like those. And so that some packets may be lost and need to be retransmitted. So look at this. All right, so we don't have the fixed delay. Instead, we have a variable network delay. right? Because of this, so it won't be easier to have the transmission. But actually, we still need to send it to the the client, and the client maybe some receive, some won't receive, and so that some will missing. All right, so that is the possible phenomenon, and we mentioned that one, but we don't have the detailed description for that. And we have some problem or some issue like that, but we still go to the architecture of or maybe some protocol to serve us the streaming. So what kind of protocol we will use it for streaming? Actually, we have the protocol called DASH. It's the app protocol DASH. Dynamic Adaptive Streaming over HTTP, so DASH, DASH. So we define this kind of app, DASH, for streaming. And we have a server and we have a client. And to have the streaming, we have the small video. So divide a video into multiple chunks, same chunks. And each chunk, the smallest chunk, and the smallest data size stored and encoded at a different rate. Different rates first, because we have the different situations, so different rate first. And we have a special file we call manifest file. So manifest file this. Can show you something to have some action. We have the manifest file, and manifest file provide the URL for different chunks. Where to get the chunks. As for the client, actually measure the client server bandwidth and consulting the manifest file, and so that request chunk at a time from the proper URL. And actually try to have the suitable one. The suitable one says client choose the achievable maximum coding given the current bandwidth. Given the current bandwidth, how to have the maximum coding rate to go through the current bandwidth. And of course, at different time, we may have the different coding rate because of the channel. All right, maybe to have the beta one, so that we have the higher coding rate to higher rate. All right, and maybe we have the bad channel, so we have the lower rate, lower transmission rate. So we may have the different coding rates, so we should find the different chunks from different URLs, and so that we still can have the entire video, even they are coming from different sites. All right, so where to find? We should have the intelligence of the client. So put the intelligence at the client, and client to determine where to request a chunk, and at what encoding rate, and when to have the proper request as well. So we should have the possible intelligence at the client, and so that the client can fully utilize the dash to have the proper chunks actually requested, and so that the chunks will be sent safely to the client. All right, so current discussion, we talk about video streaming. We know we have the encoding for sure, and based on the protocol dash. And of course, once we have the current chunks, we need to have a play out, and play out need to have the suitable buffering. And put them together, encoding dash and play out buffering, then we can have the smooth video streaming. All right, so how to do that? We need to have the suitable network to achieve it. So here we have the Content Distribution Network CDN. You see how to stream content to hundreds of thousands of simultaneous users. So a lot of users to request a video chunks. The first option, like the previous one, a single mega server. Single really large mega server. So we have a problem. Single point of failure. And maybe we have a network congestion. And maybe a long distance. So distant clients. Alright, so a lot of problem here. So it doesn't scale. Right? Doesn't scale. So we try to have option 2. Instead to have multiple servers who have multiple copies. And this kind of one we call, we should put video to CDN, distribution network, and retrieve those video chunks from different sites. So we have a lot of servers to store different video chunks, and of course allow you to have the different encoding rate. Well, even for option 2, we have multiple servers. So depending on the size, we can have enter deep and bring home. Bring home and enter deep. Alright, so enter deep actually put CDN server deep into many access networks. So enter deep, we will have the server close to users. So how many users? Oh, okay, really large number of servers to serve the clients. Bringing home says, okay, I cannot have a lot of servers, so bring them home. Bring them home here, the code. Bring them home, so we just have, for example, 10 servers. So we have two different solutions, even for option 2. But enter deep, we should have a lot of servers. Even it's really okay to have the scalable solution, but we need to have a lot of servers. Bringing home, actually, we have, for example, a few servers, but still can work easily. But we have a really huge responsibility by the few servers. All right, so we still have 2 solutions, and these are 2 solutions not equal to a single mega server, not equal to a single mega server. We may have entity to have a lot of servers, to have bringing home to have just 10, around 10 servers to serve the video to the clients. And actually for entity, we have one possible company uses Akamai, and Limelight use Bring Home. So we have 2 companies to accept the 2 solutions, enter deep and bring home. All right, so let's move on. And assuming we have a lot of servers to serve us the possible site to provide the video chunks. So we have many copies. For example, Netflix, we want to find multiple copies of a movie called Mad Men. So of course, we try to have the nearest one, so nearby copy. So how to have the nearby copy? Actually, CDN should direct the nearby copy to the client. So for example, here we have a host. Okay, where is the target file? Mad Men. So try to find the manifest file and the system direct. Oh, okay, here we have a site here. And a site, of course, is a server. The nearby server. store the copies of a madman. So just write the copy to that client, right? And possibly it doesn't mean a single server, maybe multiple servers to provide multiple copy to the client, right? So here we have the possible view, OTT over the top view. So someone like, oh, okay, we have the sites here only. All right, someone like we have the site only. And all the sites try to communicate with the client. So that is called the OTT view. All right. And let us have the closer look. For example, Bob, the current client, name of the current client, requires a video for sure. And this time we have the net cinema. Okay, and previously we tried to have the nearby site. In fact, we want to find the nearby site for sure. That's okay, but we still have the other issue. What kind of issue? DNS. We know the net cinema, but we will be served by the authoritative DNS server. And the DNS server is the King CDN. So look at this. Okay, Bob. Here I want to request a video. So you see, get URL and direct to the local DNS. So currently it's DNS, so we have the issue working with CDN DNS. And DNS, we should resolve the DNS. Okay, so send to the local DNS server, and DNS server direct to the authoritative DNS. And authoritative DNS return the solution. Okay, here. So through the resolution, DNS resolution, we know, oh, okay, where to have the corresponding name. So you see, original name, it should be NetCinema, but finally it should be kingcdn.com. So we should have the DNS to help us to find the kingdns.com to provide the stream videos. So first of all, find it, but should look up the DNS, try to resolve the DNS. So through the resolution, okay. So finally we know that one, and so we know it's the King CDN here. And so that we have the final step, request from King CDN instead of the original NetCinema. And the similar one is Netflix. So this is the user client, and send to the server. Of course, the server find, okay, we have the Netflix video. But using the manifest file, and so that we know where to fetch. But same, we have the CDN server. Okay, so we skip some DNS and find a CDN server, and so that we know, okay, even we have a lot, we have the nearby CDN server, and allow the nearby CDN server to serve Bob. So for the current one, we make it simple, and we use the manifest file, and we skip the possible DNS lookup. But for the previous one, we have the DNS lookup, and so that we know which server to serve. Actually, it's King CDN rather than the original Net Cinema. Alright, but for Netflix, actually, we take care of all these. So we have a CDN directly using the manifest file. So that says about Netflix and Net Cinema, we don't have the same solution. Because of the different solutions, so we have the different way to find to get the video from the CDN server. So this is the third one, video streaming and the CDN. Likewise, let it have 1 minute to think about CDN here. Okay. All right, so we have 3 minutes more. I mean, 3 more minutes to finish the second class. So the next one, actually, let me start. Even we have 3 minutes only. Circuit programming with UDP and TCP. And let us have the preparation for circuit programming. We mentioned something in the beginning of chapter 2. We have circuit programming. All right. So we will have the real example using Python later. All right, so we have circuit programming. So we don't know we have a door, and the door here serving as the door to the transport layer. So because of that, also we have a circuit, and this kind of programming we call it's the circuit programming. And we don't know we have 2 different choices. UDP provide the unreliable datagram, and the TCP actually we try to have some possible way to link. We have the reliable by stream oriented. So by stream oriented, so stream oriented. So we will have the datagram. UDP map it to datagram. And the TCP map it to stream. Something like streaming. So we have the mapping, and later we will have the programming mapping to have a datagram, to have a circuit datagram. Oh, sorry, stream circuit. So later we will have the suitable name. But how to have the programming? We already have the possible example. A client read a line of characters from the keyword and send it to the server. All right, and the server receives the data and then try to convert characters to upper 1. All right, so read, then convert. So we will have the uppercase. And once we have the uppercase, we need to print the modified characters and display them on the screen. So let us continue to have the details for UDP and TCP. So UDP first, no connection required. And the data may be lost or received out of order. And about the viewpoint of application, unreliable. All right. And how to have the name, we use datagram. So you see datagram. So no connections, of course, no need to have the connection preparation. So no handshaking. And we should have the explicit IP, destination IP and port number, and allow them to reach the destination. And for the receiver, receiver should extract the IP address and port number from the received packet for sure. So this is the scenario for UDP. So first of all, I try to draw your attention, SAC. It's a socket. So datagram, DGRAM, datagram. So we have the name associated with UDP using SAC datagram. And here this is IPv4. So AF internet, so it's IPv4. And server actually will set the port number there. All right, as for client, actually client we have the port number assigned by the OS, you know that one. And so we can create the socket for client, and we can create socket for the server. We should have the server and then contacted by the client, and then we can reply. And once finished, then we close the client. But for the server, we always were there, so it won't be necessary to close the connection for, and I mean to actually to recreate the server socket. No, stay there, just one. And as for the client actually finished, so we will close the socket there. So this is the possible architecture for UDP. We should have the possible name here. So this one then it will be UDP. As for the others, I think this Wednesday we will let you know all the details of UDP. Of course, you can go through the code of UDP client for sure. And actually, we will have UDP server. And after that one, we will have a TCP client and TCP server. And after that, then we finish the discussion for the content of chapter 2. All right, so that we can go to chapter 3. Well, I think time's up. And I think I have 4 more minutes to have the discussion so that I reach this page. And this Wednesday, I will continue to talk about this. And likewise, I will have the maybe the really simple question that you have the answer by going through the video today, class 1 and class 2 for DNS, for P2P, and for video streaming CDN. But for the current one, circuit programming, I think I will reserve it, so it won't be necessary to check the details for the current circuit programming. All right, that's all. The 2 classes are compensated tonight, because I think I don't have enough time, so I squeeze out the suitable time start after evening, and so that I have the 2 classes for today, and so that we can actually catch up the schedule. All right, so that's all, and I will see you this Wednesday from this page to have further discussion from this page. Okay, that's it, and see you this Wednesday. Bye-bye.